Autonomous combat aircraft are no longer prototypes, they are operational concepts shaping future wars. The shift began with drones used for surveillance, then strike missions followed. Now autonomy is moving into air-to-air combat. This transition is not about removing pilots, it is about extending decision speed beyond human limits. Modern air combat happens in milliseconds. Sensors detect targets before pilots see anything, missiles launch before visual contact. Autonomy compresses reaction time. Further, early autonomous aircraft were remotely piloted. Communication delays, limited effectiveness, electronic warfare disrupted links. Vulnerability forced redesign. The next phase removed dependency on constant human control. Aircraft gained onboard processing. Machine learning enabled pattern recognition. Target classification became automatic. Autonomous systems now manage navigation, formation, keeping threat avoidance, and sensor fusion. Humans supervise rather than control. The core advantage. As endurance machines do not fatigue, they do not lose focus. They operate continuously. Another advantage is risk tolerance. Autonomous aircraft fly missions too dangerous for manned platforms, penetrating dense air defenses, operating inside missile envelopes, executing high-loss probability reconnaissance. The airframe design changes accordingly. Cockpits disappear. Life support systems vanish. Structural layouts shift, range, payload, and stealth increase. Swarming becomes possible. Multiple aircraft operate as a single adaptive system. Each unit shares sensor data. Targets are assigned dynamically. Loss of one unit does not collapse the mission. This breaks traditional air combat geometry. Dogfights become algorithmic. Maneuvering becomes predictive. Engagements resolve before human perception. The challenge is trust. Commanders must rely on machine judgment. Rules of engagement must be encoded. Legal frameworks lag behind capability. Autonomy cannot improvise ethically. It follows parameters. This forces militaries to redefine control authority. Cyber vulnerability becomes a primary battlefield. Autonomous aircraft must resist spoofing. They must detect false data. They must isolate compromised nodes. Artificial intelligence models are trained on massive combat simulations. Millions of engagements, refined behavior, edge cases are encoded. Mistakes are removed before real deployment. The speed of learning surpasses human training cycles. Aircraft evolve faster than doctrine. Nations pursuing autonomous combat aircraft include the United States, China, Russia, and European coalitions. Programs focus on loyal wingman systems, unmanned escorts. Accompany crewed fighters. They extend sensor reach, carry weapons, absorb risk. This is transitional doctrine. Fully autonomous strike formations follow. Cost structure shifts. High-end fighters remain expensive. Autonomous aircraft are designed for mass. Attritable platforms become acceptable. Loss becomes strategic tolerance. Air superiority shifts from individual excellence to system dominance. Victory belongs to the side that controls data flow, not airspace. Future battles will not be pilot against pilot. They will be network against network, algorithm against algorithm. Autonomous combat aircraft will not replace pilots immediately. They will displace them from the most dangerous zones first. Eventually, the cockpit becomes optional. This is not science fiction. It is active procurement. The next generation of air power will not ask who is flying it, will ask who is thinking faster.